Hello and welcome back to my channel. In this video I'm going to make a CNC router. Now, I had a few specific requirements for this build. My shop size is limited, so I wanted the CNC to fit in the space under my outfeed table. As you can see, it's about 40 inches wide, about 20 inches tall. Another goal I had was to build this thing from easily obtainable parts from Amazon and using just my normal tools I have, mostly for woodworking. I also used my 3D printer for quite a few parts, as you'll see later on in the video. After taking my measurements and drawing up some plans, I started with this 20 by 20 millimeter aluminum extrusion and got them cut to length. I'll put a list in the description of everything I used here to build this thing. I think everything did come from Amazon with the exception of the parts I 3D printed. Of course, I should point out that these CNC routers can be bought already made, but I wanted the fun of building it, and I wanted the biggest working space on the bed as possible, but with the machine still fitting in that space under my outfeed table. So after getting the aluminum extrusions cut to length, I set about creating two nearly identical square frames to hold these bearing rails. And here I'm installing the bearing blocks on the rails. These will hold the carriage for the router head. These small 90-degree angle brackets made it easy to fit the pieces together and keep everything square. Now I'll get the top frame attached to the bottom frame. Now that the base is finished, I'll turn my attention to the carriage structure. I used 1/2 inch MDF for this, both because I had some laying around and because it's cheap. Originally in my plans I needed 4 identical pieces, so here I'm ganging them all together using tape and super glue. I found this to be a very effective method. The tape sticks to the wood and then the super glue sticks the tape to the tape, and everything peels apart fairly easily. Now in the end I decided I only needed 2 of these 4 pieces, but the process would have been the same either way. This is another trick I used a couple times on this project to find the bolt hole pattern so I could transfer it to the part I needed to cut out. Using a scrap piece of paper and a pencil, I can rub the pencil across the top of the part and then transfer the location of the holes and the edges of the part through onto the paper. I can then use my scribe to mark the center locations of those holes onto my wooden parts. I created this 3D printed template to mark the centers of where I needed to drill to get a tight fit for where the aluminum extrusions would go through the sides of the carriage. Switched over to a Forester bit to drill out the center. Here I'm just trimming off the corners to make it look more refined. And here you can see how the aluminum extrusion fits in those holes with hardly any slop. So now that all the holes are cut, I can take the pieces apart and I end up with 4 nearly identical pieces. So now I'll get the sides of the carriage attached to the lower bearing block. It's a little bit difficult to see what I'm doing here, but I'm moving that upper rail left and right until I can get the side of the carriage perfectly square with the table and setting against the upper bearing block. And then I'll do the same thing for the other side. Here I'm using my bolt hole template again to mark the locations for the drill. These pieces are for the bolts for the top bearing block on the rail. So now that the carriage sides are in place and relatively square, I can get the aluminum extrusions that are going to act as the x-axis inserted and then cut to length. Once I got those cut down, I tapped the ends for an M6 bolt. In order to trap those aluminum extrusions left to right, I 3D printed this piece that will use that M6 bolt into that tapped hole. I'll then use these panhead screws to attach the piece to the carriage sides. Now I'm installing just some more pieces to help stiffen things up and keep the carriage from racking. I have that pipe clamp in place diagonally just to hold everything really square while the glue dries. Here are the bearing rails I chose for the X-axis. I wanted to experiment with these two different types of bearing rails. Compared to the rails I used on the base, these were a little more expensive and they take a little more force to move the bearings along the rail. On the other hand, they do set tighter to the aluminum extrusion than those lower rails would have. Here I'm starting to build the Z-axis, but this first piece is the housing nut for the ball screw that runs the router head left and right on the X-axis. This will make more sense once you can see it installed. Here I'm just using that pencil rubbing method to get my bolt hole pattern. Once I had those holes drilled, I moved on to getting the Z-axis actuator assembly located. I then drilled more holes to get this piece attached to the bearings on the X-axis. I used the 3D printer to make this bracket that'll hold the Z-axis motor. It has a hinged design that I'll show in a few minutes that allows me to tension the Z-axis belt. Now I'll get the holes drilled for the X-axis ball screw. Now that that was finished, I decided to disassemble the carriage so that I could take the wooden pieces for paint. While the paint was drying, I installed some supports across the bed of the base. And then I moved to doing a test run on all the electronic components. These stepper motors and drivers and control panels were all new to me. So I got my parts list and my wiring diagram from plans I bought from JD's Garage. Now their plans are for a CNC plasma table, so I had to change things up a little bit. But overall their plans are very affordable and helpful, and gave me the confidence to tackle the electronic components of this project. I'll include a link to their site in the description. So once the paint was dry, I got everything reassembled. I noticed there was a little bit of racking from left to right of the Y-axis. So I 3D printed this bracket that would bolt through the bearing blocks and then attach to that aluminum extrusion to stiffen everything up. I'm going to use a Makita trim router as my spindle, so I bought this mounting bracket from Amazon. Here's the bearing for the X-axis ball screw. I had to print a little spacer there to make it fit with the length of the ball screw. Here's the first piece of MDF that I'm using to encase the base. This will allow me something to attach the Y-axis ball screw and motor to. And here's another 3D printed part that I used to mount the housing nut for the ball screw of the Y-axis. And another piece I designed to help me bolt the drag chain to the aluminum extrusion. Once I had the drag chain in place, then I was able to measure and print a bracket to hold the end of the drag chain. Here I'm getting the belt for the Z-axis installed, and I'll show that pivot mechanism that I designed to help tension the belt. I had to cut a hole to make room for the back of the Y-axis motor. And then I printed a piece to trim it out. For the motor driver and the control board, I 3D printed this box and installed a computer fan to keep the components cool. So after I got it situated and the power supply put where I wanted it, I began running wires. That's the mounting block for the ESP32 control board I'm using. Here's what everything looked like, screwed down and tucked away inside the box. So once I had everything wired up, it was time to power it and test it to see if it worked before I closed up the lid. This is just some thin filter material that I'm going to use to try to keep the dust out of my control box as much as possible. I had these T-tracks left over from another project in the past, but I do believe I got them on Amazon as well. I got them screwed down and then installed the spoil boards. So with everything installed and hooked up, it's time for a test piece. This first time I'm just running the router around the board manually, using the buttons on the computer. Here is the first attempt at just cutting out a couple simple circles. Next I programmed in just a simple dome shape to see how it would do with the 3D cutting. First I'm roughing it out with just a 1/4 inch spiral upcut bit. Here's what that looked like after the roughing pass. I then changed the bit to a 1/4 inch round nose bit to do the finishing pass. I still have some learning to do, but I think that turned out pretty well. So after I was satisfied that everything was working as it's supposed to, I got the machine placed underneath my workbench, as I mentioned at the beginning of the video. And just for extra fanciness, I converted the top of my table to a lift so that I could access the router easily. Overall, I'm satisfied with the end result. I spent the next few weeks learning about STL files and software to run the CNC machine. I'm excited to add this to my shop arsenal. With it, you can make things like this. I cut this out of an 8-inch piece of scrap wood I had, and I think it took about 3 hours of cut time on the router. I guess I'll leave you here, and I appreciate you watching.